Last video we actually talked about a lot about the poles. Okay, you remember the trends of all nyquist poles, because as you can see in the last video, we have 1 over, everything is 1 over. But what if we introduce something? Okay, what if we introduce zeros? Okay, will it change the equation? Definitely. Okay, but it will change only this portion, but it will never change how these integrators will change the things. Okay, as you can see in my nyquist plot. Okay, she plot all these things. When you multiply the 1 over s, you flip 9 degrees. Okay, that is here. If you multiply 1 over s square, okay, you flip 9 degrees, and then 1 over s cubed, you flip 9 degrees, which is minus 270 degrees. This one is minus 180. Hey, this one is minus. Hold on. Okay, yeah lah. So last video we actually talked about the zeros. I mean the poles, right? And then we can see this trend over here. If it's 1 over s, you flip this all of this in 90 degrees. And 1 over s squared, you flip again. You flip this one to 90 degrees. And then if it's 1 over s cubed, you flip this portion over here to 90 degrees. Similarly, as you can see, if it's 1 over s, they share the same trend. Okay, they share the same trend. If it's s squared, you see they share the same trend. S squared, s squared. If it's s cubed, this is when I multiply zeros into it. Okay, if I multiply when I multiply 0. Okay, and then the only difference, okay, I just want to point out, is that as you can see, this line. Okay, if I zoom out, this is actually the plot of s plus 1. This is to the so this bottom is actually s plus 1 4 to the power of 4. Okay, this is s plus 1 to the power of 4, this is s plus 1 to the power of 3, and this is s plus 1 to the power of 2, and then since this is 1, I didn't plot it. Okay, so as you can see, this is second order, this is third order, this is fourth order poles. So if you remember back ago, we talked about the zeros, right? The zeros contribute a 90 degrees positive phase. This is why in the graph over here, okay, this is the second order, this is the third order, and this is the fourth order. If you remember the fourth order in the without the zeros, it crosses into the fourth plane already, right? It crosses into the fourth plane. However, in our case, okay, in this case, because we add in 1 more zeros, we actually create a positive 90, it contributes a positive 90 degrees. So therefore, it didn't go towards this plane. So the fourth, so s plus 1 to the power of 4, okay, it didn't cross over this plane because, in other words, this is s plus 1 to the power of 4. As you can see, to the power of 4, this thing moved towards the fourth plane already. But because of the zeros over here, I'm at the third plane. Okay, so it plus 90 degrees back. Okay, so this whole thing is negative 360 degrees because the zeros s plus 1 contributes 90 degrees increase of phase, so therefore it brings it back to negative 270 degrees. This is why it's over here. Okay, so I just want to, because when I write the name down, it's essentially with no zeros, so I thought it may be good if I put with zeros, and then you may understand the full nyquist plot, like the total thing. Okay, so I'll see you in the next video for nyquist stability. Okay, bye bye.